All right, now these videos are not meant to take the place of reading this material. It's meant to help you to solve the questions that are in the worksheet. So a couple of things I do want to mention though, is that another name for specific humidity is content, or how much water is actually in the parcel of air, and the maximum water vapor is called capacity. Now this will help you when you are doing the optional activity. There's also a formula right here for calculating the relative humidity. It's just a percentage. So it's going to be content over capacity, or in this case, specific humidity divided by the maximum water vapor times 100. So based on the table, which we've already made, which I have somewhere. Oh, no, we're going to create the table. Sorry about that. Connect the points with the solid line. Okay, so plot the maximum water vapor of an air parcel in the blank graph on the right. Okay, so we're going to plot these values here. So you're going to take these numbers and you're going to plot them. It'll create this kind of like a curve, but you want to actually do it. So the first one is at, minus 40 would be just barely over the line, and then just barely a little bit higher than that, then a bit higher than that, and then at 10, at minus 10, it's at 2, and at 0, it's at 3.5. Hey, that's pretty darn close. At 5, it's at 5. Woo, dang, you think I knew what I was doing. Okay, so you want to plot those values and then put them in. This will help you with activities that are coming up, and then you'll answer these questions. The easiest way, in my opinion, to do this is to split this area here into quadrants. And what this is asking you to do is some math. So you're going to be calculating the relative humidity. So it says that just before sunrise, the temperature is 15 degrees with a specific humidity of 8.5 kilograms of water vapor. Calculate the relative humidity, show your work. So we'll just go ahead and put A, B, C, and D here. So the specific humidity or content is 8.5 kilograms of water vapor per kilogram of air divided by the capacity. So we're going to look at this table or this chart depending on if the value is over here. So it says it's 10. So kilograms of water vapor per kilogram of air times 100. And so 8.5 divided by 10 times 100 is 85%. So that's the answer to A. So you do the same thing for B and C. Again, you're going to use this value here for the content, and then you're going to use the table here to figure out what the capacity is. So that's how you do these. If the value that you're given is not on this particular chart here, for example, this one here, you're going to have to actually use your table, your graph. So make sure you draw the graph accurately. Okay, the next one, it asks you to do it in 2 different colors. If you don't have blue and red, then just use 2 different colors. A pencil and a pen will work. But what you want to do is you want to go ahead and put whichever color you're going to use for each thing, kind of like create a legend. Okay, and so you're going to use these values over here to plot the temperature, and you're going to use the values over here for the relative humidity. So for example, 65.7. So 65, these are on 2, 4, 6, these are on the 2s. I like to write down what the scale is. Let's see, 15 divided by 5 is 3, just so I can remember. All right, so like 66, just below 66. 2, 4, 6, so like right in here. It's going to be our first point, right? And then our next one is just below 62, so that would be right around here. And then 60.3, so just above the line there. And then it shoots up to 74.4. And then you're gonna connect the dots. So you'll see, you'll connect the dots there. And then you'll go ahead and do the relative humidity on the other side. So 58. So you're using the numbers over here, and these are on the 3. So this would be 48, 51, 54, 57. So 58 is just above this line. About here. And then 47 below this line here. And then again, you'll connect those however they work out. Okay, so that's that one. And then you'll answer question. Okay, and then you're going to do some more little math things here. So if a parcel of air has a specific humidity of 8.5 degrees, what is the dew point temperature? So again, you would just need to figure out when the content is equal to the capacity. So you're going to look in this column here for 8.5. It's not there, so you're going to have to use the chart. So you'll find, approximately where 8.5 is. So halfway between here is 7.5. So halfway between 7.5 and 10 is 3 point something. There's like 3 in there divided by 1.5 and then 6. So yeah, right about in here, I'd say. And then you'll come across here to wherever it is on your chart and then down. So it depends on how well you drew your chart. Remember, I just kind of scribbled that in because I don't want to give away all the answers. Hello. All right. Oh, excuse me. The next part asks you to use something called the sling psychrometer. This table information goes on the top of this up here. So I'm just going to write it up here. Relative humidity table. Okay, so a sling psychrometer is, we have a whole bunch of these in the lab there. It looks like a little stick, and on the stick is this metal contraption with 2 thermometers on it. Okay, and one of the thermometers has a little sock, and we would get that sock wet. Now, if you remember, or you watched the first one, or you read the first stuff, evaporation causes the area to cool, like the process of it going from a liquid, which is what the little damp sock would be, to a gas is absorbing, which causes a cooling of the surrounding area. So this thermometer, because the water is evaporating to the air, is going to cool faster than this guy. This guy is just going to tell you what temperature it is. So what we would do is we would go out and we'd sling these around, and the little thing would go around and around and around, throwing off water into the air. And so, for example, you might have, well, let's not use 65 because let's use 35. And this one, after we were done slinging it around for a while, let's say it was 31. Okay, so we could figure out what the relative humidity is by finding 35. Okay, and then we're not looking for 31, we're looking for what is called the depression, which is the difference between these two. So that's 4 degrees, right? So we come down 4 degrees, and our answer would be 75%, if that was the question. Okay, we can do the same thing with our dew point temperature. So if it's 35 degrees out and it goes down 4 degrees, then the dew point temperature is 30%. I mean, sorry, 30 degrees. This is a temperature, sorry. This is the percentage. All right, so then it'll ask you some questions. All right, now the next part is a little tricky because it asks you for numbers that are not specifically on the table, meaning that it's asking, see how it says 12 degrees? Well, 12 isn't on here, 12.5 is. So you could use 12.5, so you can go ahead and change that to a half. Right? And then Reading, it says it's 14, and there is no 14. So just go ahead and pretend that's 15. And it says, all right, so let's do Reading. So let's say it was 15 and the wet bulb temperature is 8. So that would be 7 degrees. So 7 degrees is our depression. So 15, 7. Oh, look at that. It's not on there again. So we'll just say it's 25%. And the dew point temperature, 15, and 7, let's say it's -6. Okay. Because this was so complicated, and I apologize, I should really change these numbers out so that it's easier to do. I just want you to know how to calculate the wet bulb depression and how to figure out what the relative humidity is and the dew point temperature. So for this particular activity, if you just fill out this column, that'd be cool. And then you can go ahead and extrapolate this. So for example, this is 14 and 9. So the depression there is 5 degrees. So we come over here to 14. There isn't a 14 and 5. So let's say it's 15 and 5. So you say it's like 52. That. You don't need to do this. And let's see here. You don't need to do this. And that's all you need to do for part B. You don't need to do this because we're not in class. So just calculate those depressions and, try a couple of these and give it your best college try on them, because I'm not going to make you do the advanced thermonuclear calculations. All right. And that's it. You don't need to do anything else. So, all right. Have a good one.